Hello, I'm Adam and welcome to this Tetris Publishing video on querying SQL Server. In this session we'll take a look at how to join tables in SQL Server queries. These are the topics that we'll be covering in this session. Firstly, we'll see how to join two tables. Then we'll move on and see how you can join multiple tables. Then we'll look at how you can simplify joining tables by using a technique called aliases. Then we'll look at how you can join tables on several columns, and finally we'll end by seeing why you should bother joining tables at all in the first place. Here we are in SQL Server Management Studio once again. I'm now going to expand the Databases folder. Then I'm going to expand the Prestige Cars database, and finally I'm going to expand the Tables folder so we can see all the tables that the database contains. These tables don't mean very much until we look at the data they contain, and for the moment there are two tables that interest me particularly. These are the stock table and the model table. Let's look at the data that they contain, and this will help you to understand why we need to join these two tables. The stock table contains a list of all the models of car that have ever been in stock, including those now sold on to clients. However, the stock table does not describe each car. All that we have to indicate which model of vehicle is in stock is a code, the model ID code. Now let's look at the model data. This table is quite succinct. However, it also contains a code, also called model ID, and this refers to the model of car as well as actually containing the full name of the model of the vehicle in another column. So if we can establish a link between the two tables, we should be able to use the data from both tables to provide a more complete data set, where the actual name of the model can be mapped to the information about that model in the stock table. And this is what SQL Server actually does. Take a look at this schematic representation of what happens when you join two tables. When you actually join one table to another in SQL Server, it uses the field that contains values common to both tables and takes the information in these fields to map the records from one table to those in the other table. It can even do this if the records from one table appear several times in the other table, as is the case here. But that's enough theory. Let's move on to a practical application of table joins. The first thing we need is a query window where we can write some SQL. But first I'm going to click on the Prestige Cars database in the Object Explorer window on the left. Then I'm going to click on the New Query button in the toolbar, and I'm going to paste in the piece of SQL that we need. OK, I could type it in, but pasting in the query avoids you watching me laboriously type a piece of code. We'll look much more closely at this piece of SQL in a few minutes. Firstly, however, I want to see if it actually works, so I'm going to press the F5 function key to run the SQL. Well, there's some output. Let's scroll down it and see what it looks like. I reckon those 911s must be Porsches, and DBs are surely Aston Martins, so the query looks like it's brought back the data that we asked for from the two separate tables. And now let's take a good look at the SQL itself. In this piece of SQL, it's above all the from clause that is essential. This clause begins with the from keyword. Well, you're used to that by now, and it's followed by the table that you want to use, the model table here. However, the next line contains something new. It contains the inner join keyword, followed by another different table name, the stock table that we want to join the model table to. Then the from clause is extended even further with an on clause. The on clause establishes the link between the two tables that have been defined in the from and inner join clauses. It's here that you specify which fields are used to map values across the two tables. In this example, that means that the model ID field in the model table and the model ID field in the stock table are joined. As you can see, you have to be really specific and say which table contains each of the fields that you are using to establish the join. This means entering the table name followed by a period and the field name itself that is contained in the table. The rest of the code uses keywords that you learnt to use in the previous video. Firstly, there's the select keyword, which is used to specify the fields that you want to appear in the output. Each required field is separated from the other fields by a comma. But it's worth making the point that the fields can come from either of the tables that are in the from and inner join clauses. And finally, we added an order by clause to sort the data. This clause must always come after the extended from clause. I realise that the first time you join tables there's a lot to take in, so here's a schematic overview of what we did. This image illustrates how a table join is just two tables and the link on the common field shared between the two tables. Once you know that two tables share a common element, you can build a join between the two tables and select any of the fields from the two tables in your query. So now, in readiness for the next step, I'm going to close this query window without saving it. Once you start joining tables, a whole new universe of SQL queries opens up before you. This is because you can use this approach to link not just two tables, but as many as you like. To make this clearer, I now want to show you how to return data in a query from 3 different tables. But as the table names may not mean very much to you yet, let me show you what I mean by this. Let's suppose that we want to extend the previous query so that we can see not only the model name, but the make name too. However, Prestige Cars in its database stores models in one table and makes in another. But fortunately though, the design of the database allows these tables to be joined, as you can see here. Stock joins to model on model ID and model joins to make on make ID. So let's apply some code to join 3 tables. First, I'm going to create a new query window. Now I'm going to paste the code into this window. The SQL is relatively similar to the code that you saw previously, yet once again the real action is in the from clause. So let's take a closer look at this. Once again we begin with the from keyword and say which is the first source table. Then we add the inner join keyword and provide the name of the table that the first table can link to. Then we complete this first link by adding an on clause and specifying which field in one table links to which field in the other table. Then comes the really interesting thing. You add another inner join and table name to introduce the third table in the dataset. To complete the process, you add another on clause and specify which field in the new table links to what field in one of the other tables that you have already introduced. The query is then completed by a select clause that defines the 3 fields, one from each table, that we want to see in the output. And even though this is not strictly compulsory, I preceded each field in the select clause with the name of the table that contains it and a period to make the code clearer. Well, so much for the theory. But does it work? There's only one way to find out, and that is going to be through clicking the Execute button in the toolbar. Well, the query certainly runs, and it returns data from several tables. So this shows you that returning data from multiple tables is another powerful aspect of SQL querying. Once you've understood the basics of how to join tables in SQL, creating complex joins to link multiple tables becomes almost routine. There is, however, one technique that can make your life easier when faced with complex code. But before explaining the solution, I want to look at the difficulty. As you can see in the current query, you end up repeating the table name several times in the on clauses and in the select clause, and even in the order by clause if there is one. This can get laborious and it makes the code hard to read. Here's the same code where the table names have been replaced by aliases. The first thing that strikes us is the code is shorter. This makes it easier to read. The way this works is that the first time a table is introduced, either by the from keyword or the inner join keyword, The table name is followed by a space, the as keyword and a short alias. Then in the rest of the query you simply replace the table name by the alias and save a lot of typing. Now to see if this delivers the same results, I'll execute the query once again by pressing F5. The query's run, but nothing's changed, and that's exactly what I wanted to see. However, the code is shorter and is both easier to write and maintain, so aliases can be a really practical trick to employ when you're writing complex SQL queries. For the final part of this video, I want to show you how to join tables on more than one field, not just on a single field as we've done up till now. The first thing I'm going to need is a new empty query window, so I'm going to close this current window without saving the SQL and open a new query window. The query that I'm about to paste in uses the marketing information table. Now, as this is fairly new, I think it's probably a good idea to show it to you before we actually start writing the query. Here's a quick look at the kind of data that the marketing information table contains. This table contains both customer names and the country where the customer resides, but there's a potential issue here. What happens if a customer is in several countries but has the same name in each one? We need to ensure that we're applying the correct spend capacity for the appropriate customer. Consequently, we need to join the customer table to the marketing information table on both the customer name and the country fields to ensure that the correct data is returned by the query. Here's the query that I want to use. I'm going to paste it in. This query selects the customer name from the customer table and then selects the spend capacity from the marketing information table. It specifies the customer table in the from clause and then the marketing information table in the inner join clause. Both tables are given aliases to simplify the code. Finally, there is the on clause, and that is what is new in this query. The on clause links on a first field, the country field that's in both tables. Then the clause is extended by the and keyword, and a second set of fields, one from each table, is added. More specifically, this means that both the customer name and the country names are mapped between the two tables independently and yet together to make the join. So now, let's run this query and take a look at the results. I'm going to press F5 to do this. The results look just fine, and there's no risk of showing data for a customer from the wrong country. To finish, I want to show you more schematically how this kind of join works. As you can see from this image, the two tables are joined on two shared fields. The fields do not have to have the same name, but they must contain values that allow the data to be mapped coherently across the two tables. Now that you've seen the technical aspects of how to join tables in SQL Server, you might well be wondering, why join tables in the first place? It can seem peculiar to break data down into all these separate tables and then spend time joining them together again when you want to query the data. However, there is method in this madness, because one of the main objectives of relational databases is to avoid the duplication of data. Put simply, if an element of data, an address say, appears in two or more tables, then every time it needs to be updated it will have to be modified in several places. This is complicated and a big potential source of errors. One classic consequence of duplicated data is that you end up with multiple different addresses, say, and no way of knowing which is the right one. Relational databases try and prevent this happening by storing independent but homogeneous chunks of data in separate tables once and once only. And another advantage of keeping data in separate tables is that through avoiding duplication like this, it makes the data less voluminous, so the cost of storing the data is reduced, which is important in these days of explosive data growth. This approach also lets you centralize reference data, like the table of countries you saw in a previous video. This is because certain data elements, such as country names, are likely to be used frequently in multiple circumstances. In this case, it makes sense to store the country name as well as any frequently used details in lookup tables. You can then use a short code to refer to repetitive data in your queries. Time to wrap up this video, so let's see the key points that you learnt. Firstly, inner join to link tables, extended by the on keyword to say which field or fields are used. The fact that you can use multiple inner joins and multiple on keywords means that you can extend your queries to cover many tables and many link fields. And of course, to make them easier to read, you can use aliases instead of full table names in much of the query. Here are a few tricks and traps to take away. Firstly, make sure you always connect to the right database or you just won't get the answers you expect. Then, knowing which table stores the data that you need really will make your life easier. See if there's any documentation. Remember as well that you can apply table names in the on clause in any order. It doesn't have to be in the order that the tables appeared in the join. Then one interesting thing is that if a field has the same name in more than one table, you have to specify which table the field comes from in the select clause. But you can use an alias for this, which is why aliases will make your life so much easier. Thank you for watching. I hope that you enjoyed this short session and that it will encourage you to continue learning all about querying SQL Server. And remember, if you need a full and progressive introduction to querying SQL Server, you can always take a look at our books on this subject. These 2 volumes can help transform you from a SQL novice to an analytics maestro. To find them, just go to Amazon.com and search for Query Answers with SQL Server. Alternatively, visit your local bookstore. If you want to download the sample data that you saw in this video, as well as the SQL queries that we used, then navigate to www.tetraspublishing.com/SQL Server. Here you can find the sample data for download and practice querying it using SQL Server.